Hello everyone, myself Ashish Desai, Assistant Professor, Shell Institute of Technology, College of Engineering. Today we are going to discuss the composite material. So the introduction to composite material. So actually the composite material are engineered materials, so made from two or more distinct constituent materials with significantly differently physical or chemical properties. When combined with they create a material with enhanced the properties and that are superior to the individual components. So this is the terminology for the composite material. So we are adding two or more materials which is having for improvisation of the properties, or you can say the superior components we can make with this composite areas. So now what is the importance of the material, or what is the importance of composite material? So first is high strength to weight ratio, so which is stronger than metals but much lighter will be there. Then corrosion resistance, so it is unlike the metals but composite are resist to the rust and degradation. Third one is the customizable properties that can be tailored for the specific mechanical and thermal or electrical needs, so we can improvising by the that properties. Then durability, so for longer lifespan, the compared to the many conventional materials, so useful for the that way. This then we are comparing with any conventional material, so it is more more you can say high strength, weight ratio, corrosion resistance. So this mainly we are benefiting with a comparison with conventional metals. So we are deciding the communication comparison with conventional materials. So the property field for the metals, polymers, and composite. So we are comparing with three way areas. So if you check by the strength, so very high strength is in a composite team, but in case of the strength is much high, low is in polymers. So it is quite high in metals. But in case of weight, so very light weight is in polymer and composite is present, but heavy is in a metal sides. Then corrosion resistance, so it is higher side in the composites, but in case of comparing with polymers, it is in a moderate manner, or you can say in metals that is in requires with coating and required for the treatment purpose. So that is then it should be higher side. Customizability is limited in case of material, in case of metal material. So but in case of polymers it should be high, and composites it very high. So then cost, if you cost is about the moderate to high, but in case of polymer low, but it is should be varies for the initial cost because of varying the that compositions. Depending on composition, the composite material should be cost is high. So these are comparing areas for the with the conventional materials. So this is the classification of composite materials. So polymer matrix composite, that is we can say PMCs, metal matrix composite, that is MMCs, ceramic matrix composite, that is CMCs, and lastly that is hybrid composites. So this is mixture of that. So this is called as hybrid composites. So first of all, we discuss this about polymer matrix composites. In a matrix material, there are the polymers are present, and reinforcement we are called as a glass fiber or carbon fiber, or in can say of different fibers we are attaching as a reinforcement. The property will be the light in weight, high strength, and corrosion resistance. So these PMC materials we are using in a aerospace and automotive or sports equipments. So this is the benefit of polymer matrix composites. Second, that is about metal matrix composite, that is MMCs, that is about matrix materials. So here is the matrix is a metal. So the name indicates the metal matrix, that is metals which is in the form of aluminum or can say titanium and magnesiums. For reinforcement, we are adding the silicon carbide or boron fibers. So properties for the high strength assistance or resistance and superior strength will be provided by the metal matrix. The applications, that is about aircraft structures and engine components, or against the defense areas. These are the applications areas for the metal matrix composites. The next we are having with ceramic matrix composites. So this is matrix material. So ceramics which is having with silicon carbide or aluminum oxide is present as in the form of matrix. And for reinforcement, that is about ceramic fibers, carbon fibers, and the properties should be extreme heat resistance, wear resistance, and brittle in nature. That is about the property of ceramic matrix composites. The application which is useful in aerospace, automotive braking system, and nuclear reactors. So this is the application area of ceramic material, that is ceramic matrix composites, that is CMCs. Next is the combination, that is about hybrid composites. So two or more reinforcements or matrices is formed, that is carbon glass fiber reinforced polymers, that is you can say CG fiber reinforced based polymers, which is the properties to be in that is improved in a metal mechanical properties, improved in a damage resistance. The application area is high performance structural components in aerospace, automotive, and biomedical sectors. So this is about the hybrid composites. So these are the properties. Actually, we are discussing this four. That is the classification of composite material, that is from PMC, that is polymer matrix composite, metal matrix composite, then ceramic matrix composite, and hybrid composites. But now we are going to discuss the era of the properties. So first property is high strength to weight ratio, that is stronger than metals is possible, and which is useful for in the aerospace, automotive, and sport applications. So it reduces weight without any compressive strength, compromising strength. So this is about the first advantageous property. Then corrosion resistance. So it is useful in marine structures, pipelines, and chemicals industry, that is for the storage tanks. Then fatigue resistance, the composite can be stand with repeated loading cycles and without significant deteriorations, so it is possible. Then improve the reliability in aircraft bridges and wind turbines blades. So this is about the fatigue resistance also possible, so which is improved in reliability. Then fourth one is thermal and lateral properties. The thermals, in a thermal case, it is having with a high resistive temperature. So high temperature resistance metal, that is ceramic matrix composites for the aerospace applications. Then electrical properties, that is insulating for any conductive, that is carbon based composites. So that is also improved over here. These are the properties can be offered to the performing for the that any equipment. So this is comparison with conventional materials. Then now next list, that is about manufacturing techniques. So it is having a different manufacturing techniques is available: hand layup, the spray layup, then resin transfer molding, that is we can call it as RTM, compression molding, then additive manufacturing, that is use of 3D printing. So these are the manufacturing techniques is available for the manufacturing the composites materials. So some highlighting the applications of composite materials. So firstly, that is about aerospace, automotive, marine, sports equipment, and biomedical. So these are the main applications which is available. The nextly, that is about advantages. So these are the many advantages are there. So light in weight and lower density, high creep resistance. So any temperature you can resist over there. Then strength to the weight and stiffness to the weight are greater than the metal property, that is metals. Then fatigue properties are better than common engineering metals. Also, composites cannot corrode like a steel. Easy of fabrication, so large structural applications or large shapes we can model as per that requirement, so easily we can formulate over there. Then ability incorporate with sensors, so easily monitor the performance by using in this smart composites. Then high strength to the impact damage, then high resistance to impact damage, then improve the corrosion resistance. So these are the advantages points we are discussing here. The dis or can say limitations of the composite material. So high cost of raw materials and fabrication costs also more. Then composites are more brittle than wrought metals, and thus are very easily damaged. Transverse properties can be maybe weak. Matrix is weak, therefore low toughness property. Then reuse and disposal may be difficult to attach. Then difficulty with analysis. The next one is cost can be fluctuate according to the combination of the materials. So these are the limitations. So here in that session we are discussed the properties of the composite material, comparison of conventional materials, as well as we are discussing the advantage, disadvantage, applications, and different manufacturing techniques which is useful for the composite materials. So these are the content we are discussed in the this lecture. Thank you.